All right, last video I'm going to make for today. So this is how to approximate non-perfect squares. So if you're watching this video, hopefully you have most of your perfect squares memorized or you have a pretty good idea what they are. This is how to approximate the ones that are not perfect. This is the next level up. So if you notice here, the example I have on the board is the square root of 52. It's not a perfect square. If I were to draw a square that had the area of 52, these side lengths would not be nice integer numbers. I would get decimals, and more specifically, I would get irrational numbers as answers. So yes, there is a square that exists. It's just not a perfect square because the side lengths are not nice whole integers. So we need to approximate a number that we can work with, because I just said it really comes out to an irrational answer. But I want to make a rational approximation that we can work with. So the process is like this. I have to find the two perfect squares that surround this number. If I'm good with my perfect squares, I know that that is the square root of 49 and the square root of 64. Right? These are the two perfect squares that are closest to this number. The square root of 49 comes out to 7. And the square root of 64 comes out to 8. So what that tells me is the square root of 52 is somewhere in the middle. The value of it is somewhere in the middle of 7 and 8. And I should also be able to tell that it's closer to 7 because 52 is closer to 49 than it is to 64. So I have an idea that square root of 52 is somewhere between 7 and 8, but definitely closer to 7. Now I can take it a step further. I can get a pretty good decimal approximation. This is how it's going to work. So first thing, I want to check out how far apart these things are. Well, 49 and 52 are only 3 spaces away from each other. 49 to 52 is 3. 49 to 64 is 15 spaces apart. So if I were to look at this, I'm part of the way there. 3 is the part that I'm going. 15 is the whole way. So I'm going part of the total distance. 3/15 is my fraction. Right? I went 3/15 of the distance. This can be simplified. Divide the top and bottom by 3. That's 1/5. Now what I have to do is I have to turn that 1/5 into a decimal. You probably have this one memorized. 1/5 is 0.2. Now that doesn't mean the answer of the square root of 52 is 0.2 because we already said it's somewhere in between 7 and 8. What this does is this gives us the decimal portion, because anything between 7 and 8 is going to be 7 point something. Well, there's the point something. We just found it. So what we're going to say is the square root of 52 is approximately 7.2. Now, notice I said approximately. The real answer for the square root of 52, let me go off camera for a second. If I type this into a calculator, square root of 52, if you can see that, it says 7.211, and then it goes on a really long time. Now, did we get that exact number? No. But did we get a pretty good approximation that we can work with? Yes, that's the idea of these problems. So, steps again, just to recap. Find the perfect squares that surround your number. Evaluate them, so you have an idea of what numbers it's in between. Find the distance from there to there, perfect square to the non-perfect square, in this case 3. Find the distance from perfect square to perfect square, the total distance. Turn that into a fraction. Turn that fraction into a decimal, and you have your answer. It works the same way with any other examples. I think 1 is probably good enough. Again, if you have any questions, let me know.